Hey guys, I wanted to do this in a little bit more refined fashion, but just to get something quick to you, I'll run through a very quick and dirty way to do this, to create contours from a DEM. So to start, I get my DEMs from the Earth Explorer, and you'll want to select an area. I'll just quickly define a small portion there. On the data sets, if you go to digital elevation, I'll do the SRTM. This is DEMs created from satellite missions. And on additional criteria, you don't need to do that, but I'll just do the 3-arc. If I'm looking at a very large area, the 3-arc has a lower resolution. And then on results, you can click on these little overlays to see kind of a little preview of the area that's represented. And when you find the sets that you want, unfortunately you have to download them all separately. So if I wanted this entire area, I would have to download each one of these by clicking this little download button here. Now when you download these, you'll have to log in first of all. But either one of these will work if you just import it as a lone file. If you want to create a data set, you would want to use the DTED format. So I'll just I would recommend doing the DTED. So let me hit cancel because I've already got a couple of these. Now when you first import those into ArcMap, I've already downloaded a couple. So here's one right here. I'll go ahead and add that. Now it brings it in as just a solid color at first. That's because it's applying a very large set to it. That just needs to be, the symbology needs to be adjusted. So if you right click, go to properties, go to symbology, create statistics, and I can see I have a high and a low value here. So I'll do two things. I'll change my color ramp and do the minimum maximum. I might need to change these. You can type whatever. Or you might just want to type the numbers. Now these vertical units are in meters. Keep that in mind, very important. So there's my color DEM. Darker is lower. Actually I've got that, yeah, the dark is the low value, the lighter is the high value. And you just need to know that that DEM is in meters. You can tell that actually just by studying the data. So back at Earth Explorer, if I click this little info button, scroll down, and I can see that meters is my vertical units. So that's one thing to keep in mind. The coordinate system is actually defaults to feet. So our X and Y units are in feet. It's kind of confusing, but it'll hopefully come together here in a little bit. So let me go ahead and remove that because I wanted to show you a way to do multiple. If you want to mosaic these together, there's really only one way to do it. And you have to create a mosaic data set. So before you add these, you need to essentially create the infrastructure to house them. And you'll need the catalog view open. That's the little icon here. And once it's over here, I think we can just, yeah, we can pin it so it's always off to the side. But we want to first create a database, and then we're going to create a data set, two separate things. Then we'll add things to the data set. So that's what I'll be doing now. So step one, go to maybe wherever your default folder connections are. I'll go ahead and right click, say new, and I'm creating a file geodatabase. So there it is. Just keep the GDB at the end of it. Let's call this GDB. All right. So now that is on my desktop. Step two is to set that as your default database because there's always a default geodatabase. When you don't predefine it, it just defaults back to the default. So you want to right click and say make default geodatabase. All right, so that's one step. Next step is to create a data set. So right click on that database and you want to go to New and Mosaic dataset. Now these are all different, but since we actually want to mosaic these, not simply add rasters, we want to select Mosaic dataset, which is a type of raster dataset. Click on that. And this takes a little while for ArcMap to complete. Just let it run for a bit. You'll get the little walkthrough wizard here. The output location is the database, your default database. The data set name, we'll call this, now notice I'm adding underscores. I don't think you can use spaces in this. Coordinate system, those particular files are set to the WGS84, and that one, once you're here, let me back up. So still this wizard, hit the coordinate system. I will do a select geographic world and WGS 1984 projection. Okay, and don't worry about the pixel properties. All right, so after all of that, now ArcMap thinks a little bit. Keep an eye down here because we should eventually see a little status update. Or not. Oh, there it is. Just gotta wait. So once that is created, we've got the structure, but there's nothing in it. We need to add files to that. Back in the catalog, back to the My File database. Let's expand that, My DEM set. Right click on that data set, and then you would want to add rasters. So the actual first step is downloading all of these so they're somewhere on your desktop. The raster type is a raster dataset. The input, let's select workspace. That's if you want to just choose a folder. If you did file, you could do them each individually, but I'll go ahead and select workspace, and then all I need to do is find that folder right here. Now, you don't want to double click on it. Just go ahead and highlight it. Also, anything else you've got in that folder should just be ignored. So I've got some other junk in here, but it should only look to the raster files. Actually, I do have one extra raster file in there. I'm going to get rid of that because that might cause a problem. So I'd recommend just keeping your DEMs in a lone folder. That'll make things a little bit easier. All right. So we got that selected, hit add. Very important, you do want to update overviews. And these other ones, don't worry about. We'll just leave those to the default. Let's hit OK. And once again, let ArcMap do its work. It might take a couple minutes. And once it's completed, you should see this. If you see a little red X, that's bad. You can click on that to get a little overview of the processes that just happened. All right, so now if I right click and select zoom to layer, this structure automatically gives you a boundary, a footprint, and an image. Because when you stitch all of these together, you may or may not want to turn that off just because it's easier to navigate around. But what's important here is they're stitched together and they are seamless. If you brought these in individually using this button, the highs and lows wouldn't match up. And essentially that means like a white value here would not be equal to a white value over here in terms of elevation. All right, so all of this is just to mosaic our data set. So as large of an area that you want to create contours from, you would need to follow these steps. The next step, now if you wanted to jump straight to the contours, you can click on the Arc toolbox right there, right above my little spinning icon. And you want to go to Spatial Analyst Tools and Surface and then Contour. We could just go ahead and run that. The downside is because this is a raster data set, it's very pixelated. Let me go ahead and zoom in. And as a result, you'll end up with some very jagged, that's actually not too bad, but you'll end up with some very jagged, potentially jagged contour. So, you can go ahead and try it, but if you want to kind of smooth out your raster first, you can go ahead and apply what's called focal statistics. That's under the neighborhood toolbox. So focal statistics, you just go ahead and specify your raster. Give it a circle for the neighborhood settings. Radius, the lower, the less destructive it is. The higher, the more smooth the process is. And the statistics type is mean. That is fine. So I'll go ahead and run that. And once again, we wait. Keep an eye down here. The nice thing about this is that it is non-destructive. We're not going to destroy our other value or other import. It just adds a new set up here. And now that actually looks like it did the opposite of what I was looking for, but so there is my original one. If I turn on my focal statistics, you can see it's kind of grayed out, but you lose some highs and lows. Presentational wise, it'll give you a little bit smoother, and especially at this scale, you're not going to want to get every little crevice to show up. Otherwise, it'll be a very large file and very jagged. So I'll go ahead and just pick this top one and turn that one off. For this next step, doesn't matter which one you got. The process is the same. I'll go back to my arc toolbox, and this time I will select contour. So I'll go ahead and walk through what this means. Input raster, go ahead and select just a raster, hopefully a DEM, in your file. The output, it'll go to your geo database, whatever your default geo database is. We can't save this directly to a shapefile quite yet, but that's all right. We'll do that in another step. Contour interval, what do you want these contours to be? Now, this is where it gets tricky. Our units, our vertical units are in meters. Our X and Y units are in feet. So we have to do a little bit of math here. For the contour interval, type what you ultimately want it to be. So if I want this to be every 10 feet, I'll still type 10. Base contour, leave that for now. The Z factor, here is where we adjust, we put in a multiplier to get to our default units. If I leave it at 1, it will create contours every 10 meters because that's the vertical unit. If I want this to be feet, I have to put in 3.281 because that's about how many feet are in a meter. So you can also read on the side here. It gives you a little overview of everything I just explained, probably in a little bit clearer fashion. But all right, that all looks good. Let's hit OK. And we will wait. So you'll see that this creates a very detailed drawing, but it has all of our contours at hopefully 10 feet intervals. If we can turn off these other items here, you can see it's very large. There may be a couple, it's actually not so bad. Sometimes you'll end up with little lines, or again, if you get the jagged edges, that is where the focal statistics may or may not help alleviate that. I'm going to go ahead and zoom to that layer. So very, very large file. From this point, you can export this to a CAD. Just by right-clicking, go to Export CAD. There are ways to figure out, to assign the numbers to each individual polyline, but at least if you can get this far, you are on the right track. If you want to check your math, so to speak, you can label these features. It's not styling the features, it's just applying a very quick dynamic label. And you do that by right-clicking and select Label Features. Now, if you do that, you're going to see these numbers don't seem to mean anything. Obviously, we're not jumping from, whatever that says, 1696 to 1993 feet. That's because it's not labeling it with the correct attribute. If I take a look at my attributes, I can see I've got a random ID number, the shape attribute, the ID, and the contour. Contour is what you would like. So right click, properties, under labels, for the label field, let's go ahead and select that to contour and hit OK. And there, now we can see that these numbers look a little bit more believable. I think this area is right around 860 feet. If we go back there once again, we can add an expression. So we'll say contour, and I just put in quotes feet. Let's see if that works. Oops, I didn't like that. Plus feet. So now it's added feet. Again, that's just a dynamic layer because if I zoom out, it relabels it. Now, if you really want to check just to see if how close that is to what exists, you can add a base map from right up here. The first time you do this, it likes to think a little bit. And I'll go ahead and add the US topo maps. Now, I'm not quite sure why we're not seeing it here. There it is. I'll zoom in on an edge here. It might just be that my internet is kind of slow right now. Or there's a level of detail where I can't zoom in. But what you should hopefully be able to do if you do this on your computer is see that it lines up pretty close. It's not going to line up exactly because it's two totally different ways to derive and represent contours, but hopefully this will give you enough steps where you can be a little investigative and hopefully get to what you need on your own. Otherwise, just let me know if you have any questions.